Hello, this video is for IXL activity 8.X.7. It is titled Graph Solutions to Two-Step Inequalities. The three-character code for this activity is Whiskey Hotel Tango. So we've solved and graphed one-step equations or one-step inequalities in a previous lesson, and we learned that solving inequalities is a lot like solving equations, and we use the same properties, and we undo subtraction with addition and addition with subtraction. We've learned that the inverse properties of multiplication and division, that we can undo each of those using the inverse properties. And so just like we done in the lessons where we solved equations, now we're going to solve inequalities. And again, we've done one step once. Now it's going to be two-step equations. And pretty much one of the things that we learned whenever we were doing one-step equations was that for the most part, it's almost identical. The only thing that we really have that's a difference is different is that we have to change the sign. We have to flip the sign if we multiply or divide by a negative. Now, I believe, if I recall, whenever I did this activity, I didn't come across any of those, but if you do come across any of them where you have to multiply or divide by a negative number, be sure to go ahead and reverse that sign. So let's go ahead and get started. It's best to rewrite the problem. So we'll start off with 9x, and actually I did some work earlier using black, then we'll switch over to red. If you watched any of my videos, you know I like to use the red ink. So 9 plus 3g is greater than or equal to 6. So we need to get rid of this 9 first before we can deal with that multiplication between the 3 and the variable g. So let's go ahead and subtract 9 from each side, because what we do to one side we have to do to the other. The 9's are going to cancel each other, leaving us with 3g. Bring down that greater than equal to sign, and 6 minus 9 is going to be negative 3. Now we can deal with the 3 that's tied to the g, so we're going to divide by 3. The very number we wish to get rid of, and we are dividing by a positive number, so we don't have to flip the sign. The 3's will cancel each other, leaving us with g on the left. Let's bring our greater than or equal to sign, and negative divided by a positive is negative, and 3 divided by 3 is 1, so we end up with g is greater than or equal to negative 1. So now that we have that solution there, we need to graph it. And a little bit of review here. I'll probably not talk about it too much in the following problems, but we want to make sure that our variable is on the left, because that allows us to use that little cheat, right, to realize that the arrow is going to go in the same direction that our inequality symbol is pointing to. And the other thing we need to pay attention to is open dot or closed dot. Remember, if it is greater than or less than, then it's open dot. Right? And if it is greater than or equal to or less than or equal to, then we're going to use the closed dot concept. Okay? That's because open dot means that that point is not included, and closed dot means that point is indeed included. So in this case, it could be negative 1. So we're going to go ahead and do a closed dot there, and then we want our arrow going to the right. Right, because it's all the numbers that are greater than negative 1 or equal to, thus the closed dot. And we could always check our answer by selecting a number that's in that set of numbers that are solutions to it. So we can go ahead, and I always like selecting the 0, right? I'm trying to write with a line. There we go. I always like selecting 0, because anything times 0 is 0, right? So we plug a 0 times 3, we end up with 0. So we can look at 9 is greater than or equal to 6. Indeed it is, so we know that our arrow went in the correct direction. All right, next one. We have 2y plus 8 is greater than 4. So we're going to have an open dot here, right? Because it does not include the equal concept. So let's go ahead and subtract 8 to get rid of that 8. So what we do to one side, we're going to do to the other. The 8's are going to cancel each other, leaving us with 2y on the left. Bring down our greater than sign, and 4 minus 8 is negative 4. Now we need to divide by 2, because the 2 is tied to the y through multiplication. So let's go ahead and divide by 2. It is the number we wish to get rid of, so that's why we're dividing by 2. We're going to the 2's will cancel each other. We are left with y on the left is greater than negative divided by positive is negative. 4 divided by 2 is 2. So y is greater than negative 2. So it's going to be all the numbers to the right of negative 2. And we know we're going to the right because our variable's on the left and our sign's pointing to the right. So let's look at negative 2. It is an open dot, and we're going to go to the right. So everything over here to the right. Now in IXL, remember that whenever you do this, click once for an open dot, click again for a closed dot, and then click on whichever end of the number line that you want the arrow to go, and it'll put that in there for you. Next one, we have 8v plus 10 is greater than or equal to 2. So let's first deal with this positive 10. So we're going to subtract 10, and what we do to one side, we're going to do to the other. And the 10's will cancel each other, leaving us with 8v. Bring down our sign. And 2 minus 10 is negative 8. Now we can go ahead and divide by 8 so that we can isolate this variable of v. What we do to one side, we're going to do to the other. The 8's will cancel each other, leave me with v. Bring down my sign. And negative divided by positive is negative. And 8 divided by 8 is 1, so v is greater than or equal to negative 1. Notice the equal than portion. It should be a closed dot. Click once for open, click twice for closed, and all the numbers greater than negative 1 are all those values to the right. Again, you could go ahead and grab a number like 0, plug it in there. 8 times 0 is 0. Is 10 greater than or equal to 2? Indeed, true statement, so we know our arrow went in the correct direction. Here we have 9 plus 3, and that's tied to the variable p by multiplication, is less than 3. So let's go ahead and subtract 9 to get rid of that 9. What we do to one side, we're going to do to the other. And the 9's cancel each other out, leaving us with 3p is less than. 3 minus 9 is negative 6. And then we're going to divide by 3, right? Because we want to get rid of that 3. What we do to one side, we do to the other. 3's cancel each other, leaving me with just a variable p. My sign remains the same, and negative divided by positive is negative, and 6 divided by 3 is 2. So our solution for this inequality is p is less than negative 2. That means all the numbers to the left of negative 2. It is an open dot because we don't have the half and equal sign there, and we're going to go to the left. Now, this one here, I want to show how we can use numbers that are not part of the solution to test. Remember how I used 0 and I plugged 0 in to test it whenever 0 was part of the solution set? Well, now I'm going to use 0 to go ahead and test it, and I should get a false statement because 0 is not included. So if I plug 0 into here, 3 times 0 is 0, and 9 less than 3, well, that's a false statement, right? That's not true. And that makes sense because 0 is not part of our solution set. So you can use that value of 0 to test your answer to make sure your arrow went in the correct direction, both whenever 0 is part of the solution, because you would get a true statement, and you can use it whenever it's not part of the solution because it would produce a false statement. So kind of a little trick there you can use. Here we have 16 plus 14c is greater than 2. So let's go ahead and get rid of that 16 first. We're going to subtract 16 from each side. And the 16's will cancel each other out, leaving us with 14c. Bring down our greater than sign. 2 minus 16 is a negative 14. Now let's go ahead and divide by 14, right? And now the 14's will cancel each other, leaving us with c. Bring down our sign, and negative divided by positive, again, is a negative. And 14 over 14 is 1. So c is greater than negative 1. So let's find our negative 1 on the number line. Open dot. And we want it to go to the right. We want all the numbers greater than negative 1. That's what that sign means. And remember also the symbol, the inequality symbol is pointing to the right, and our line also goes to the right. On the next one, we have 19. I'm trying to write with a line again. Works well for a 1, but it's not going to work well for a 19. Is less than 12h minus 5. So let's get rid of this negative 5. And also notice that our variable h is now on the right side of the inequality, but we'll deal with that after we find out what h is greater than or less than. So we'll deal with that part in the later portion. So let's go ahead and add 5 to get rid of the negative 5, because remember, negative 5 is the same as plus a negative 5, so we need a positive 5, so those cancel each other out. Let's not forget what we do to one side, we do to the other. Our sign's going to stay the same, and those 5's canceled each other, leaving me with 12h on the right, and 19 plus 5 is 24. Now let's go ahead and divide both sides by 12. We're doing that because 12 is the number we want to get rid of. And 12's cancel each other, leaving me with h. Bring my sign down. 24 divided by 12 is 2. And now 2 is less than h, which this is the same thing as h being greater than 2, right? And we can write that by putting the h on the other side and the 2 on the other side, so they just reverse sides. But notice that the inequality symbol is pointing at the 2. Well, we can go ahead and write it that way. It's still pointing at the 2. Well, 2 being less than h is the same as h being greater than 2. So you can change their positions. Just be sure to flip the sign. And this is helpful. Why? Because the symbol tells us which way our arrow needs to go on the graph, as long as our variable's on the left. That's why I like to keep them on the left over there. So that's going to be an open dot, right? And we're looking for 2. And I want my arrow going to the right. It's been a little while since I checked my answer on the last few, so I can go ahead and check that, test that. So 0 is not part of the solution. So if I put 0 in there, this should make a false statement. 12 times 0 is 0. So scratch that out. Is 19 less than negative 5? No, that's not a true statement. So that makes sense because 0 is not part of the solution set. So my arrow must definitely be going in the correct direction. Here we go with this one here. 32 is greater than 12b. Again, the variable is on the right, correct? Put that minus 40 there. So let's go ahead and add 40 to get rid of the negative 40. What we do to one side, we're going to do to the other. And now those 40s are going to cancel each other out, leaving us with our 12b on the right. And 32 plus 40 is going to be 72. And I believe if we divide both sides by 12, that the 12 is going to cancel each other, leaving us with b on the right. And 72 divided by 12 should be 6, right? 6 times 12, 72. Well, 6 times 10 is 60. 6 times 2 is 12. 60 plus 12 is indeed 72. So b is greater, or 6 is greater than b. Well, I could change that around, flip their sides. It's pointing at b, so I'm going to make sure it continues to point at b. So b is less than 6 is the same thing. So let's find 6. It should be open dot because we don't have the equality concept with this sign. And we want to go to the left because we want everything less than 6. See how 6 is greater than b? Yeah, I guess that makes sense, right? 6 is greater than everything to the left. But I also like the idea of thinking about it this way, of saying the variable first, right? Saying that b is less than 6. It just seems to make more sense to me, just personally. So it's up to you whichever way you want to do it. I just like this little trick of having the variable on the left so that I'm sure that I'm getting my symbol going in the correct direction. All right, another one here. Oh, looky here, we got a fraction, right? So I was waiting for them to get just a little bit harder. K over 8 plus 62 is less than or equal to 63. So this is up in the higher level, maybe the 80s or 90s maybe, before you're going to get to those fractions there, usually. So let's go ahead and subtract 62 minus 62 from each side. And those 62s are going to cancel each other. And 63 minus 62, well, that's pretty easy, right? That's going to be 1. And then I have k over 8 still. Now, the 8 is tied to the k through division because every fraction is a division problem. So the opposite operation is multiplication. So I want to multiply. And I want to multiply by 8. That's the very number I wish to get rid of. And what I do to one side, I'm going to do to the other. It's been a little while since we had multiplication, so I'll throw all that in there. The 8's are going to cancel each other, leaving me with just k on the left. Bring my sign along. And 1 times 8 is 8. So I end up with k is less than or equal to 8. So we have the equal portion. So we need to go ahead and make a solid dot, and everything less than 8 is going to be everything to the left on the number line. So we want our line going to the left. I think I had a few more questions in here than I hoped for, but we'll go ahead and keep getting these done. G over 2 plus 1. There we go. So let's deal with the 1 first, right? So let's go ahead and subtract 1, or that is to say we're actually adding a negative 1 to it, right? And so we're going to add a negative 1 over here as well. We think of minus 1 as plus a negative 1. And I kind of like to do that so we don't get confused over here. Many people would get confused and maybe make this a 0 on the left. And we know that negative 1 plus a negative 1, well, that's just going to get more negative and be a negative 2, correct? And that positive 1 and negative 1, well, those are going to cancel each other out, leaving us with G over 2. Now we have the relationship between the variable G and the number 2, that denominator there is division, so we need to multiply. We're going to multiply by 2, which is the number we wish to get rid of. And what we do to one side, we're going to do to the other. The 2's are going to cancel each other, leaving us with just G. And positive times negative is negative, and 2 times 2 is 4. Now my G's on the right, I want it on the left, and I want my negative 4 on the right. You notice that the arrow's pointing at G, so we're going to keep it pointing at G. Now let's go ahead and graph our solution and find negative 4. There it is. It does have the equality concept, so we'll go ahead and fill that in. And it is pointing to the left. It's all the numbers that are less than or equal to negative 4. So there we go for that. Now, we could test this. It's been a little while since we checked our answer, so let's go ahead and plug 0 in there. So 0 here. 0 divided by 2 is 0, so that's just going to go away, right? So we end up with negative 1 is greater than or equal to positive 1. Well, that's not true, right? Positive 1 is greater than negative 1, so it should be the other way around. So we get a false statement, and that makes sense because 0 is not part of the solution. And finally, we come to our last one. So it looks like we're going to make it all the way through without having to multiply or divide by a negative. I don't think that I came across any of those. Just remember, if you do, you need to switch the sign if you multiply or divide both sides by a negative number. So here I want to go ahead and get rid of this 1. So again, I'm going to add a negative 1 or subtract 1, however you want to look at it. So plus negative 1 on both sides. The positive 1, negative 1 are going to cancel each other out. And negative 1 plus negative 1 is negative 2. It's still negative 2 since we did the last one. And J over 4. And now I need to multiply by 4 to get rid of this 4, right? And what I do to one side, I'm going to do to the other. And now 4 times negative 2 is negative 8. Keep my sign, and the 4's cancel, and I'm left with J. Now I want the J on the left and the negative A on the right. Notice that it's pointing at the 8, so we'll keep it pointing at the 8. And now we know that J is greater than negative 8. So let's find negative 8. It should be an open dot because we don't have the equality concept, and we want it going to the right. All right, so those are all of my examples for IXL 8.X.7 graph solutions to two-step inequalities. Good luck with your activity.